Hello, everyone. My name is Tucker Schoblad. I'm a product manager and developer advocate at Tableau, and thank you all for joining me while we learn more about how to build on Tableau's platform. Today, specifically, we're talking about connectivity, and what that means to us is that we're going to talk about the Hyper API and Connector SDK. To put a face to the voice, I put together this handy slide. I live in Seattle, where Tableau is headquartered. I'm a big skier and tennis player, but let's just brush over this. Let's get to the agenda so we can start planning out what we're going to talk about for the next 30 minutes or so. So to begin, we're going to open with the Hyper API. We're going to get an overview of what the API does, what it's capable of, talk about some use cases, and then see it in action. After that, we can point you towards some helpful resources and guides to get started with. After running through the Hyper API, we're going to turn over to the Connector SDK. Again, we'll get a quick overview of it, see it in action, talk about how it works, and learn more about how customers can leverage what our partners have built so far. This might be a little bit of review, but let's just take a look at these high-level buckets that represent the types of integrations enabled through Tableau's developer platform. So the developer platform enables a huge variety of use cases, right? This includes automation and integration up in the top left there, enabling people to seamlessly integrate Tableau with existing workflows. This includes things like the REST API, webhooks. There's extensibility, which enables integrating external applications like web applications into dashboards via the Extensions API. I think you've already heard about this, but this is one of the more exciting parts of our developer platform. Not that they're all not exciting, but I love dashboard extensions and the work that our customers and partners do with those. We have advanced analytics. This area is about enabling things like R and Python and MATLAB, these advanced statistical and machine learning capabilities into the product. You obviously have the ability to embed Tableau content into other applications via the embedding API, JavaScript API. And last up, we have the corner that I specialize in, really, which is our data connectivity area. So again, today, we're going to be talking about the Hyper API and the Connector SDK. Just ways to bring more data into Tableau's platform. Step one in an analytics workflow naturally is going to be to connect to your data. And we want to enable as many people to get access to their data as possible. Okay, so up first, quick overview. What is the Hyper API? But let's take a step back. What is Hyper to begin with? This could be a new term to a lot of people listening in here. Well, Hyper is a next-generation general-purpose data engine. It's built into every Tableau product, SQL-based, highly scalable. It's optimized for both reading and writing these hybrid workflows, and it's really fast. It's basically this awesome database technology that Tableau bought from this startup out of Munich, Germany. And it's now at the heart of all of our different products. So to kind of show you really what it is, I'm going to actually open up a copy of Tableau Desktop, and we can all see it for ourselves. So give me 1 second here. Okay, so this is a new workbook in Tableau Desktop. I've connected to a Postgres table, as you can see up in the top left. And to highlight what Hyper really does in our platform, I'm first going to point our attention to this top right corner where we see these two different ways that we can connect to data. So these being live and extract-based connections. Now, a live connection is really just what it sounds like whenever I come to a new sheet in Tableau Desktop, or for that matter, open up a dashboard in Tableau Server or Tableau Online through the web browser. I have the ability to start clicking and dragging and querying, right? So if I brought out my order IDs and the profit on each of those, or maybe wanted to color by quantity, even could just really see this in action, just change these around. Maybe I don't want to look at my order ID. I could look at my different states. You get the idea here that every time I take an action with this dashboard or load it or click to filter on a dashboard, that is generating a new live query that is headed to my Postgres database. In this case, what we're really doing is something akin to select state sum of profit group by state. And Tableau, being the amazing product that it is, knows how to translate my interactions with a given, worksheet or dashboard and turn that into a SQL query. So we really just wrote a bunch of SQL just by clicking and dragging. And what live indicates here is that each of those queries is going back to our original data source. But there are a lot of times when you don't want every query to go back to your original data source. Maybe the data doesn't necessarily need to be up to the second live like those queries were. It could be a table that gets updated every few days or once a week or once a month, or maybe it's a system that a lot of other aspects of your business depend on, and you don't want to place that analytical workload onto your Postgres or Redshift or Mongo instance, something like that, right? Well, in that case, we have the ability to create an extract of this data. Now you can see from the tiny text in the top left there, what it's doing is it's importing your data into Tableau's data engine. And the extract is created when you click on the Sheet tab. So if I create an extract of this, what it's doing is basically just running a select star, bringing everything from this table into a local file type called a .hyperfile. So this is that hyper technology that we were just talking about. Now, when I actually go to a new sheet, it's going to ask me to save this someplace, right? So I'll go ahead and save this .hyperfile, a local copy of my of that table from Postgres. And now every time I start to click and drag, right, maybe I add city to the mix, this is no longer reaching out to that original database, and instead is leveraging that extract that we created of it. Now, part of it too is that we don't want this data to go stale. We don't want it to be an old copy of it, right? So we use the power of Tableau Server and Tableau Online to publish these data sources and have Server and Online do the work of refreshing them at a cadence that you choose. Could be once a day, could be every few hours or once a week. Tableau Server actually has all of the initial credentials that we typed in to get to that table, so that data can stay fresh. So that's just a bit about Tableau extracts. I can turn back to the slides here. So now that we've seen what Hyper is, let's go ahead and talk about what the Hyper API is. Well, the Hyper API is, as you can probably guess, an API that allows you to interact with the Hyper technology. So it lets you create, read, and update local .hyperfiles. It comes in a variety of languages, so Python, Java, C++, and .NET. And importantly, it doesn't depend on any other Tableau product as well. It basically is a standalone installation that lets you do exactly what we just saw by creating hyperfiles, but also a ton more. So it's more powerful and flexible than kind of what you just by default have access to when installing Tableau Desktop or Tableau Server, right? We'll talk about the kind of the evolution of it in this next slide here, but these bottom bullet points really highlight a lot of important functionalities of the API generally. So it allows you to load or copy data directly from CSV files, huge performance, or really great performance there with the ability to copy directly from these text files. You can update individual rows of data or delete data from hyperfiles. These databases, we can call them database files almost, right? So this full CRUD capability via the SQL-based API lets you fit the Hyper API into just a huge number of workflows that we'll see in a second here. But first, let's just talk about how the Hyper API came to be. So it started off with the Tableau SDK. And this was back in the days before we had Hyper technology built into our product. So we called these old school files .tde, data extract files. And basically what this let you do was insert data into the single table extract files. So nothing super exciting. In a weird naming convention twist, we released the Extract API 2.0. So this was the first instance of Hyper being available. It let you insert data into hyperfiles, also create multi-table hyperfiles, which is exciting. But again, just really that creating and inserting element, not that full CRUD capability that we see from the latest and greatest, the Hyper API, that is not only available in more languages, lets you do all the same things that the old versions did, but also crucially features these CRUD capabilities of updating data, deleting data, reading from hyperfiles, and having this fully SQL-based API that you can take advantage of, literally allowing you to send commands and queries to hyperfiles. And we'll get into that in a little bit. I'll show some examples of what that looks like, but that it's huge amount of flexibility for customers who want to get more out of their extracts, right? So, huge question, right? When do I use the Hyper API? Well, the Hyper API has, a big variety of places where it can be very helpful, but to kind of boil them down to a few buckets here, custom data sources is one. We're going to talk more about custom data sources as well in the second half of this presentation with the connector SDK, but a lot of like web-based data. If you want to hit an API, like a RESTful API that returns data, from some sort of SaaS application, the Hyper API can fit into that. As long as you can get the data from there, you're able to build it into a hyperfile and lean on the rest of Tableau's developer platform, like our REST API or TSC, the Python wrapper for the REST API, to publish data on a schedule automatically up to Tableau Server or Tableau Online so that people can take advantage of it. And it's through these scripts that pull data down from custom sources, and using the Hyper API to build these extracts and publish them, it solves a lot of challenges from getting data from, we'll call them, strange places. Additionally, if you wanted Tableau to fit kind of more nested into any sort of custom ETL process that's already underway, let's say you use Jupyter notebooks to do some advanced statistical modeling with Python. You aggregate data and run some, statistical analyses on the data to create new columns. And, maybe typically that pushes out to another database table or pushes to flat files. Instead, you could have the end result of that custom ETL flow literally be the Hyper API creating Tableau extracts and using our REST API again to publish those up to Tableau Server. Additionally, applications like Calibra or Alteryx. Alteryx is a great example. Alteryx uses the Hyper API to, as well as the REST API, I'll say, to create .hyperfiles at the end of Alteryx flow. So huge partnership there, and obviously, there's a lot of advantage to joint customers of Alteryx and Tableau for those applications to work really well together. And we already kind of talked about, some of these advanced data workflows, but one that comes up all the time for me in talking with customers is complicated incremental update scenarios, where let's say you've got 500 million rows in a table, it's 100 columns wide, and using Tableau Online or Tableau Server to refresh it could sometimes just take 4 or 5 hours. It's just how long it takes with your backgrounders having a lot of different tasks to do. So what the Hyper API allows for is to offload a lot of that work from your database that's, maybe running a complicated stored procedure, or from your backgrounders on Tableau Server that are, constantly running long full extract refreshes, because standard incremental updates can't look back at old data and make updates, only bring in new rows of data, right? So this CRUD capability that we're talking about with the Hyper API lets you fit in more complicated incremental update scenarios when data can be really big and when the time for standard extract refreshes can be quite long. Hopefully, the gears are already turning about how you could, offload a lot of work from your Tableau server machine, from your database machine, by implementing something with the Hyper API. Okay, so switching gears here a little bit away from the use cases, let's talk about what actually goes on when you run the Hyper API code. So you've got an application, you've got your client code leverages the front end of the Hyper API. So we're going to do some live coding in Python. Get excited, some live coding in Python today. So we'll talk about the methods and objects that exist in Python, but we've got this front end code. You've got the back end, these DLLs. We're not going to really go into that, but it's all to say that you connect to what's called a hyper process. So this hyper process, via your application has this SQL-based connection, and it can interact with, not just one hyper file, but it could be many of these different databases, these different hyper files, to do all sorts of different tasks, individually or between them. So again, you can see here that you start with your client code, you work via this SQL-based API, all with the goal of using this hyper process that you've spun up to interact with different databases or these .hyper files. So we've talked about it a bit, but let's see a big list of all the stuff you can do with the Hyper API in a .hyper file. In the bottom right, I'll just call it quickly, you can see what's available via like the interface at the high level of the API, things that you don't need to write SQL for. And then in the blue, the darker blue, you can see what you would be writing SQL statements and commands and executing them on the Hyper file itself. So first up is data ingestion. You can create brand new Hyper files, create tables within them, define the columns, insert data and append rows of data into these tables. You could also use SQL to do this highly performant bulk insert of data from CSVs directly. You can do some of these CRUD functionalities that we're talking about. So updating and deleting. You can update individual rows of data, update multiple rows of data. You can do these scans to kind of supplement incremental update scenarios. You can delete rows, you can delete whole tables, you can read data, like I mentioned, scan tables, do complex SQL queries on one or more tables. So these are things like, joins and unions, all fully possible within the Hyper SQL, with the API. And, a lot of times some important stuff too, it might be kind of underrated, but reading metadata. From multiple Hyper files. So reading the schemas and table names, getting column definitions, reading the types of data in the columns. I know for a fact that these last examples that we brought up are crucial for true application integration. For Alteryx being another great example of that. Okay, so before we jump in and see some of the code in action, just gonna plug some of the amazing resources that we have available. We've got a full GitHub repo with samples written in every language and some really great use case specific samples that I'll highlight a few in just a second. And fully fledged documentation available on our site. But also, if you have an idea for an integration, you've got a customer that you'd love to potentially see use the Hyper API, absolutely reach out. Let's get on the phone and see what Hyper and the Hyper API could do for them. So we have some really great community samples, we call them. They're not sourced, they're not written by our community, but they've got this community level of support badge, so that's why they're called that. But fully written and vetted by Tableau and Hyper engineers. So a bunch of really great kind of use case specific examples are also available in addition to the standard samples written in every language. So things like pulling data down from S3 or defragmenting hyperfiles that might have seen a size ballooning. scripts that help deal with geographic information, or sometimes some important end-to-end workflow examples. I've talked about the REST API a number of times, and really important to mention that the Hyper API and the REST API are sort of like, a fine wine and cheese. They pair really well together. The idea being that the Hyper API doesn't really know what Tableau server is, doesn't know what Tableau desktop is, doesn't know what a project or a site is. All it knows how to do, and it knows it well, is interact with .hyperfiles. Makes sense. So why do we need the REST API? Well, because it can help turn, part of a workflow into an entire end-to-end workflow, meaning that you could have a script that downloads a data source, a .tdsx file, opens it up, finds the hyperfile within it, since it's really just a zip. Anything with X at the end of it in Tableau speak is really just a zip file. We could, swap that new hyperfile out that we made via our custom script, and then package it back up and publish it to that same site, same project on the online or server, and give it to all of our end users, the people like our explorers and viewers who really depend on that web browser and these published and curated data sources to answer their important questions. So you'll hopefully get a sense of why the REST API is so important to the Hyper API, and a lot of these samples do a fantastic job of illustrating what it looks like to use both together. Okay, with that, I'm going to jump out of the slide deck here, and we can start looking at some code. Give me one second. Okay, we can start it off super simple, right? So I'm in VS Code, which is my editor of choice here. And again, we're going to be working with Python here, but again, important to mention that we've got a variety of languages, and the Hyper API is written to work very well in every language that it's available in. So it's not like you're porting a library into Java, and it takes advantage of all of the the syntax available in Python, Java, C++, to be as performant and intuitive as possible. But for this one, let's just do a really simple example, right? Let's do the classic hello world example. We're brand new to coding, so let's see what it's like with Hyper. So starting off, you saw kind of in that high level workflow slide that we need to start up a Hyper process. And so in Python, we get to say with our Hyper process, telemetry, we're going to send usage data to Tableau because we're kind here. And we're just going to call this Hyper. So we're starting up our Hyper process, and now let's create a connection to a Hyper file. Really quickly, I'll pull away from the code just to show you that this is the directory that we're working out of here, this Hyper directory. And if we go into this databases folder here, this directory here, you can see that it's empty. So this is where we're going to create some .hyper files to load some data into, to connect to, do some cool stuff with. But right now it's empty. Just wanted to show you that. Even still, we're going to create a connection, and this connection is going to have endpoint Hyper endpoint. Super exciting to watch me code, I know. But here's a good part. We're going to say database gets. We're going to say /databases, that directory that we were just in. And we'll call this one hello world.hyper. Now, this file doesn't exist yet, so importantly, we're going to add this create mode, which is create and replace. There are a lot. We could leave it unspecified and have it throw an error if the Hyper file doesn't exist if we try to connect to it. But in this case, we're going to create it. If it exists, we're going to replace it. And we're going to call that our connection. So now, in theory here, we have a connection via a hyperprocess to a file. So what I'm going to do is, we'll leave that for now. I'm going to print something, but first I'm going to type out what we're going to print. With our connection, we're going to execute a scalar query. You can see on that list there, if I type connection dot, we could execute a command, a list query, a regular query. In this case, it's going to be a scalar query. And that query in SQL here is going to be select hello world. So if I just ran this right now, nothing would happen because we want to actually print the output of this, right? So let's throw this into our print statement. We're going to print hello world. So let's go ahead and run this file and hope it works like a charm. Hello world. There we go. We didn't just do any regular print in Python. We executed a select statement generating this, column here, hello world, this scalar query, and we printed that all through a hyper process. So, woohoo! Example number 1 done. I think this is a great one to start with because it shows off kind of two of the most important parts of working with the hyper APIs, that you need to spin up a hyper process and you need to create a connection. So again, you can connect to multiple instances of hyper files. You can have multiple connections, but in this case, we created a new database. If we came over here, we can see this hello world hyper. Not going to be a lot of data in it, but we now have the ability to use HyperSQL, execute queries against it, and see the results of it, right? Okay, so switching to our second example, we can see that we're leaving this good stuff up. Importantly, we're going to be talking about the weather. Who doesn't love the weather? So we've got this hyper weather data, hyper database here that doesn't exist yet, but we're going to create it because of this create mode with our connection. Now let's actually set up some real table with some real data in it. So for this, I'm going to create something called a table definition, and that's going to get table definition. And let's say we got our table name. That's going to be a table name type with. We'll just call it like the default in Tableau when you save single tables. It's called extract. And we've got a number of columns that we want to define to go along with it. So an example of a column looks something like this. I can do a table definition dot column here. So we got a column. We're going to call it temperature, and it's going to contain, comma. It's going to be a type double, probably, right? So we add that. Nullability, we're just going to say it's not nullable. Not nullable. Throwing me something weird here. Did I do something wrong? Let's see. SQL type double. Nullability gets not. It's okay. I'm sure it's gonna be fine. So in this case, we've got this column here. Let's just go ahead and copy and paste the rest in to save everybody some time. So if we just select this line, we can go like that. And probably want one more. I don't know, the indenting is okay. And we'll bring this all back. All right, awesome. So what we just did, it might have seemed a little convoluted at the time, but we just set up a table definition for a table within this hyper database. So what that means to us is that we now, after, if we ran a little bit more code, we would have a hyper file called weatherdata.hyper with this table structure and all these columns. and we can go ahead and actually add some data to it, right? But first, let's go ahead and do a couple quick things like calling our catalog to create our schema. That's important. This is our extract schema, extract, comma, extract, right? We can call connection.catalog one more time really quickly here to create the table, because we're just defining the table right now. We need to actually pass this in via the Hyper API. And now let's add some data, right? So we can say with our inserter, which is a method here that we can call our connection and our table definition. So hey, when we insert data, where are we inserting it to? We're going to insert it to with this given connection to our table that we just defined. Call it our inserter. And let's just add some rows. I'm gonna go ahead and copy paste this because it is not too exciting, but we'll just add some some arbitrary data here. In this case, it is weather for 3 cities at this very exact moment in time with their latitudes and longitudes, and the name of the city. Of course, they match the order in which we define these columns, right? Temp, date, lat, long, name. And last but not least, we can actually just call execute, actually do all this stuff, add the data to our Hyper file. So let's go ahead and do this right now. Okay, so no warnings, no errors. That's fantastic. Let's look at the fruits of our labor here. We can see we've got weather data. Fantastic. We can open up that same Tableau workbook we were using. Let's create a connection to it. And voila, we've got this extract, the schema extract, and the columns that we defined. So date type pulls that in great. Lats and longs, that's awesome. We can even go to a sheet, a new sheet, and we could even map these out, right? So, yep, just like that, we've got our data from these 3 different cities into a Hyper file. Yeah, we'll leave it open. Okay. So, let's see, how much time do we have? About a half an hour in. Okay, for now, let's just do this. Let's look at some other examples of code. We won't type them all out, but I'll just highlight some of the important bits just because I do want to, respect everybody's time and get to the second half of my presentation here. So let's look at something. We'll look at that one. Not that one. This one. And this one. Okay, awesome. So, in this last example, we manually define the data, right? That's cheating a little bit because in theory, what the Hyper API actually does is not just, defines tables and creates them like we see here, but also can take advantage of some more of this CRUD capability. That was just writing data. But what about doing a bulk copy from a text file, a CSV file, again, super highly performant into one of these tables? Well, this is an example of that. So everything above this we've seen, but let's take a look at these lines here where we can actually create a command, which is, just this string that takes, a table name and, a path to a text file here. And actually, this is a SQL command that we're looking at, right? So we're going to copy into a table, given these kind of text file formats. So with our format null, our delimiter, it's got no headers. And then we can execute a command against this hyperfile. So this is really working with SQL, like working with a SQL database, like you were in, dbeaver or something, right? And lastly here, we'll talk about how you can, we'll just show how you can actually, work with multiple hyperfiles, and we'll see what that looks like, where I still created my initial connection, right? But down below, I called this method to attach a new database. So you can see we got 1, 2, 3 different hyperfiles that we're working with here, all with the goal of actually doing a join between them. So we can see we've got our 2 original tables here. We've got the end result, which is this airport's weather database. And you can see the command is to create a new table by doing a select star with an inner join on a given join clause, right? It's super cool. You can create these really complicated, kind of database schemas and setups, do joins. We didn't exactly see it here, but if I were to pull up this example, you can do things like, query different rows of data. You could delete rows of data that match certain conditions, right? So delete from this table where the name gets Munich. This could be like an update data, where, certain clauses are met. So these are good examples to say, hey, okay, I get what it does, but what does the code actually look like to implement, some sort of incremental update scenario? Well, it could look like this, where you're actually doing a table scan, finding the affected rows, updating them, and then again, pairing with something like our REST API. One last example here, our REST API to go ahead and actually publish that hyperfile back up to server. So again, a lot of code here. I'll be sure to share all of this out so that you have access to it. You can, again, go and take a look at our GitHub samples. But, hopefully you're excited about the Hyper API. You want to learn more, get a bit more hands-on, see how it could benefit customers. But, yeah, that's about the short of it. Okay, so let's switch gears now to the Connector SDK. All right, so a bit different than the Hyper API, but hopefully, again, you can see how it fits into that bottom right corner of the Tableau developer platform and solves, one of the key questions of how people get to their data. So, often when working with data, there's a problem that, Tableau is great at helping people see and understand their data, but, what if your data lives in a place that Tableau doesn't connect to natively? We learned how the Hyper API can help out there, but the Connector SDK is also a great means to that same end. And we'll see some of the advantage of working with the Connector SDK in just a second. But first, let's highlight what is a Tableau connector. Well, we have a bunch of them baked into our product already, some 60 connectors native to Tableau, like when you do a clean install and open it up, right? What the Connector SDK lets you do is create new native Tableau connectors. So we can see on the right side of the screen here that we've got a bunch of connectors. It could be Azure SQL Data Warehouse, it could be Databricks, it could be Alibaba Max Compute, but we also have this custom one that we loaded into our Tableau environment, and we did that via this taco file here. So Tableau connector TACO. We like to have fun, but the important part is that once I bring this into my Tableau repository, into my Tableau environment, we can find that on this list in Tableau Desktop, connect to this demo connector. So the idea is that if internally, or maybe you work with a partner technology like Dremio, that's not a native connector right now, but with a .taco file, you can give end users that exact same experience of connecting to a previously non-native data source like they would any other. And it's all through a really simple installation process. And again, so what is the Connector SDK? Well, it lets you build and test these new connector plugins that you're building. So seeing what it looks like in action, right? I will, again, turn to trusty Tableau Desktop. And let's take a look at my Tableau repository. So in my Tableau repository, A bunch of really important directories here. We'll gloss over them though, but in any case, we've got this connectors folder, and within that, I have a new .taco file, a new Tableau connector. It's called signed Postgres ODBC taco. So, it really could be anything. We'll kind of ignore the specific that it's a Postgres connection, but the great part is that I have this in my directory here, and I'm actually able to come up to connect to data, and we can see in the big list of all of these different servers that we connect to natively, we have this new one, which is our, it's pretty much just Postgres, but it's our version of Postgres. It's Postgres ODBC by our signed test company. So if I wanted to connect to that, it'd be really easy. I could just open it. I'd have that same exact experience of working with data that I'm so used to in Tableau. I could do things like joins, publish data sources, create calculated fields, anything that you'd expect to do in Tableau Desktop and Tableau Server are possible via this connector that we just built with the same friendly native experience that our end users are really familiar with, right? So, that's just, it's a really short demo, right? Because it's just like connecting to data with any other Tableau connector, except for this time, it's using a .taco file that we placed in our Tableau repository. So, turning back from the experience, let's talk about what makes up the SDK. Well, the Tableau Connector SDK, which is publicly available on our GitHub page, it lets you create, test, and crucially tune JDBC and ODBC based connectors. To tie things together, right now this doesn't support any sort of web data source. So web data source is fantastic for the Hyper API, but if you have a JDBC or ODBC based data source, the connector SDK could be the perfect fit for solving kind of any data access needs that your customers might have. So we've got a bunch of Tableau partners that we've worked with already. We'll talk about those in a little bit. But the idea is that you can use them natively in desktop and server with online and bridge support and Tableau prep support as well coming down the pipe soon. Crucially here as well, you need to be in version 2019.4 and later. Fun to note here, I like this slide. We're not just recommending that partners and customers use this SDK. We actually eat our own dog food here as well. And so every connector in the box here, Azure SQL Data Warehouse, MariaDB, Databricks, Kivos, Qubole, the Alibaba Cloud, these are all connectors built internally off of the connector SDK. So it's the future for connectivity in our platform. We're using it, and we encourage our customers and partners to use it as well. So what's in a taco? What's the shell? What's the filling? Well, a connector is really just a collection of files. You saw it in that kind of packaged version, that .taco version, but it's really just a number of files that come together to make it. And this view might seem complicated, but don't worry, we'll step through the important parts here. The key thing to know is that it is based on 10 plus years of development work of building connectors within Tableau. So our connectivity, is simply exposing this ability to customize and build on top of the native connectors that already exist, which is huge for partners who want to, get their name on that big list of connectors in our product. And again, don't worry if it all seems complicated. The idea is that you've got 5 or 6 different files here, and they all feed into getting this signed Postgres ODBC taco, something that we already know and love because we saw it in action. And again, just to take one more quick look at this, if you see any funky file extensions like .tcd, .tdr, tdd, don't worry about those. All of these files really are XML and JavaScript. So it's not even really like coding. It's more just about understanding your driver and your database and helping, kind of optimize and tune that connection via driver capabilities or changes to a SQL dialect that will help Tableau and a database kind of speak the same language, right? Hey, before we talk about that, let's look at a connector, right? That could be fun. So I'll pull one onto the screen here. So this is a Tableau connector. This one's fun. I called it Tucker DB. Again, hello everybody. My name's Tucker. So I like to name my fictional database company after myself. We can see here that this is a ODBC-based plugin. We're looking at the manifest file. Kind of ties them all together, right? It's like the shell of the taco in this analogy. It's got this class TuckerDB. I've got some nice support links, and then crucially here, I told Tableau a bit about how to handle what my database can do, deep in its query pipeline. So when Tableau loads this connector, it also gets some hints that it cannot create temp tables. That's a no-go, but I can do a select top into. I can do a select into. I can do some of these, subqueries. I can't do partial aggregation. This is where somebody who's really familiar with a driver and a database gets to come in and say, hey, this is what it can't do. This is how we should optimize, performance, all these different good things live in these capabilities or customizations made in a dialect, or in a manifest file. Next up, we've got some JavaScript here. This basically just, helps out with building the ultimate connection string or connection URL, pairs well with this driver resolver that kind of creates this set of attributes and helps match with a driver. Lastly, this really crucial file that I want to spend some time looking at is the dialect file. So to think back to when we were talking about the live versus extract connections in Tableau, I mentioned it, but every time you drag and drop something, Tableau's generating some SQL. But by default, this is some very generic SQL. And, we want it to be as easy as possible for a database to really properly understand what Tableau's asking for when it, implements a find function. So what this dialect lets you do is actually pick between a big list of already available dialects that ship with our product to kind of inherit these dialect base classes, or basically say, my database is very similar to Postgres or MySQL, and therefore I want all queries to essentially be translated into that MySQL or PostgreSQL dialect. Additionally, you always have the option of, adding individual functions and say overwriting, in this case, the find function. And so if an end user of Tableau ever used find to search a string, either with 2 parameters or 3 arguments, in the function, you can customize the actual SQL that will get generated and sent to your database. And say the same thing for any sort of date function or aggregate function, a cast in this case. You really have, with this dialect file, full control of tuning and optimizing the SQL that gets sent to a database, right? Okay, so that's a pretty nice overview of all the files inside of Taco, but turning back to the SDK here, the SDK is not just filled with great documentation and samples and tools to, package and sign your .taco file, but it also includes this test harness, Python-based test harness called TDVT. So basically, TDVT, what it does is it simulates a huge variety of tests that could be very simple. It could be pretty complicated SQL, but the whole idea is that it simulates what end users might end up doing in our product, right? And basically, it runs about 850, 900 tests and lets you understand and diagnose where the SQL is not getting the expected results, or maybe a function isn't properly implemented. Lets you troubleshoot, learn more, and basically go back to your dialect and make improvements. There is a full guide on leveraging TDVT that I've created. I'll have the link to it, available with this recording, so that you can go and check that out as well. But the whole idea of TDVT, just to sum it up, is we want to make sure that your connector is optimized, that the data it's returning can be trusted, and TDVT is an excellent test harness to do just that. Last up, I'm going to plug the extension gallery. So this is the home of taco files that our partners have created. You can see that we've got 12 on the gallery at the time of this recording, some of which are in beta as they were just released. But in any case, we've got this centralized place where you can go and learn more about these different connectors that our partners have built. You can try those out if you have customers that want to connect to Elasticsearch or something like MarkLogic. We've partnered really closely with their engineering teams to create these high quality, high performance connectors that fit extremely natively into our product. So if you want to learn more, you can email me and Pierce Young, who works more closely with the extension gallery. Yeah, it's really exciting stuff. I love seeing more partners use the connector SDK to benefit our mutual customers, and I also love to see a lot of customers at other accounts build their own in-house connectors that can solve some of their data needs. So it's not all about partners building. We see a lot of customers who are actively engaged in engineering with the connector SDK as well. End of the slideshow. So just to bring it all home, thanks so much for spending this time with me. I hope you got a lot out of it. Please reach out. I'd love to have conversations with you to learn more about how the Hyper API or Connector SDK could help solve some of your kind of data challenges, right? I encourage you to not only dive into both of these technologies more, but our whole developer platform. It is filled with some seriously awesome stuff. So if you have any questions, feel free to reach out. Again, my name is Tucker Schoblad. Please drop me a note. Thank you again for spending this wonderful time with me. I've enjoyed recording this because I love talking about the Tableau developer platform. Got a big smile on my face over here. But anyway, cheers, everybody. Thanks again.